right, next one is question number 37 on module 6 homework. Decide whether the normal sampling distribution can be used. Remember that number of success, n, oh, that's not n times p must be at least 5, and also, and I remember this is one of your final exam review problem, n times q, the number of failure. All right, the number of failure also has to be, oh, sorry, got the wrong symbol, greater than or equal to 5. Okay, and what is q? This is the same as 1 minus p, okay? 1 minus p, stop it. Okay, so let's see if that condition is met. Stop. P is 0.22, n is 100. Well, it's gonna be met because if you do, look, 100 times 0.22, that's 22. So n times p is 22. That's greater than 5. If 22 is p, what's q? Q is 1 minus 0.22. So q is 0.78. And what is n times q? This number times 100, that's just going to be 78. So both numbers are at least 5. So yes, can the normal sampling distribution be used? Yes, because both NP and NQ are greater than, oh no. Let's see if this is the same problem. But that's all you have to do really. Just have to mention that both NP and NQ are greater than or equal to 5. Okay? Okay, now because we can go on, we have to do the rest of the problem. It says, state the null and alternative hypothesis. Let's see. Look at the claim being made. Claim being made is saying that p is not equal to 0.22. Because the symbol is does not equal to, this must be the alternative hypothesis. So the null is the opposite of that. So the null has to say p equals 0.22. I think I did one problem where I had to click on test cannot be performed. And that's what you have to go with. It's that n times q or n times p is not at least 5, okay? Determine the critical values. Select the correct choice below. So let's see. What's the critical value if alpha is 0.10? And I showed you how to find that critical value using t-distribution, right? And we're going with this time, we're not using t-distribution. That was the previous one. For the proportion, you are using normal distribution, okay? T-distribution is when you are testing a claim about mean and you do not know the population standard deviation. But for P, you're using normal distribution. Okay. All right, let's click on Stat, Calculator, and go to Normal. All right, over here, click on Between. Why am I clicking on Between? Because look at the alternative. Alternative is P does not equal to 0.22. This is two-sided test. One-sided test alternatives are P is less than or P is greater than. When it says P does not equal to 0.22 in the alternative, that makes it a two-sided test, two-tailed test. That's why I'm going to this between calculator, and the mean and the standard deviation remains the same, but these are the two boxes where my population, the critical value will pop up. Now, what's the alpha level? 10%. So, how much do we want in the middle? 90% in the middle. And we want the 10% outside. So here we go. We found it. The critical values are 1.6449 and 1.64, comma, where's my keyboard? 1.64, comma, negative 1.64. That's how you can look up the critical values for proportion, okay? What about the find the z-test statistic for this particular case. So let's go find that using z-stat or proportion stat, because you are doing a test about p, the proportion. So for that, StatCrunch calls it proportion stat. Okay, so proportion stat, one sample. I'll show you all the steps that I'm clicking on. Stat, proportion stat, one sample, and with summary. Okay, the sample size was 100, right? But what's the number of success from that sample? Now they didn't give it to you, but they gave you that p hat. The sample proportion was 19%. So if you do the sample size of 100 times 19%, you get that 19 people are in this success category. So how do we find this number of success? You do n times p hat if they didn't give that to you already. We're doing a hypothesis test assuming that the null is p equals 0.22. And the alternative is p does not equal to 0.22. And that's all you have to do. All right, let me compute. And the standardized z-test statistic is right here, negative 0.72. Round to 2 decimal places, so that will be it. Let me type this in. All right, what about that p-value? Well, you know, they don't want you to use the p-value method. They want us to use the rejection region method. So I'll go ahead and talk about that now, okay? Look, the rejection region is anything smaller than negative 1.64 and anything greater than positive 1.64. Negative 0.72 is actually in between these two numbers. So it's not in the rejection region. We're going to have to say we failed to reject H0. The data does not provide sufficient evidence to support the claim. Or the data does not provide sufficient evidence to fail. We're going to have to just say fail to reject or not, but I'm just reading part A and D, looking for the difference. Data provide, but you know, whenever you fail to reject, you just don't have evidence to say anything really. So I'm gonna go with A, and that was the correct answer. But if you want to go with the p-value method, which I like better instead of the rejection, the rejection region method, alpha level 0.10. But look at that p. P is 0.46. 0.4689 is greater than 0.10. So remember, when p is greater than the alpha level, we have to say we failed to reject the null hypothesis. So when you use StatCrunch, it's much easier to make conclusion based on the p-value. But I noticed that some of your homework questions are asking you to use the rejection region method, which will always give you the same conclusion. But that is it for question number 37 on Module 6 homework.